So everybody, welcome to the lecture on microservices. It's the 14th lecture, and we are at the very end of the winter term 21-22. And so we mainly do a wrap-up today. It's actually not that much that I need to tell you anymore. You have already learned it all. Oh, is this so? Oh, that's no good. Yeah, we have been to deploying our stuff to Heroku last week. How did that go for you guys? Who managed to deploy two services at Heroku? So it was an easy one. Great. Yeah. So, well, actually, Heroku, no. Let's be honest about this. This deploying on a cloud server, it's not the fault of Heroku, it's just this deployment. That is really, it's so annoying. It's such a hard thing. So who did it with, who needed, like me, about more than 10 approaches to get it running on Heroku? Who did more than 20? Who only needed 5? Anybody who did on the first shot? Actually, nobody. No fucking way. So yeah, and it always takes about some 5 to 10 minutes to each deployment attempt, and then you get this wall of messages from Heroku. And you need to actually watch it carefully, what's going wrong, to identify your fault. And it's also all the time very confusing. So what can we actually do about it? So actually we need a new generation of software engineers. It is you guys to actually solve this. Come up with better tools, come up with better processes, come up with better languages, come up with help on this. It's really annoying, and it's hard, and it's always hard. So one thing that we might do next year is we could do it earlier. So when we actually started to do the warehouse front end, as soon as there is a little bit of functionality, we might already set up the deployment chain for Heroku on the very third lecture after all. That would actually facilitate some things, because we would learn on deploying the front end a lot about of the things that we need to do for the warehouse backend in order to make it deployable. We would have learned that you need this port variable to be used. That is, well, actually, a special thing from Heroku. You would know some kind of scripting. Well, actually, we do deploying by actually doing this git add, git commit, git push Heroku tail command. That should be scripted. That should be a file, and that should be an npm command, so that it is actually done automatically. So that actually we need a scripting chain that does, after some development steps, I can just say, okay, please deploy. Then it should run again all the tests, and then it should automatically deploy. And that should be a single line of command in my environment. That is what you usually do. So we are yet still quite away from this. Last week we have had this nasty problem that it was working on my computer and it was not working on Heroku due to something, we call it DLL hell, the dynamic linked library hell. And dynamic linked library is the name that Windows is actually using for this. And under Linux, they call it usually a shared library. and it's basically an idea that you do not compile all parts of your system into a single executable, but there are some libraries that you share with others, with other programs. The first library you probably share all the time is libc. This is the basic library who provides math to you, and that provides file I/O to you, and graphical user interface access. So these are really basic stuff, and everybody uses the same thing. And okay, the problem is if you use a bunch of libraries, as we do in our npm JSON package. Let's start this guy. I have no idea which one I have up here. Probably pretty much. Oh no, it looks good. Let's go for some Microsoft frontend is great. Package.json. Let's get rid of all the others. Here we are, and let's get rid of this one. We have these dependencies. Here we use a lot of Angular stuff. We use Bootstrap stuff. We use Express stuff. We use RxJS, things I never heard about. And actually, many of these things use third-party libraries too. So if we go for the Node modules, yeah, is it? So this is all the libraries that we actually use. There's something like Babel, which is actually translation usually. I have no idea. Base 64, this is probably used for encryption. I have no idea. Brace expansion, pretty interesting stuff. And look at this. This is quite a list of libraries. And most of them I've never heard about. I have no idea. These are libraries that are used, example given, by Angular or by Bootstrap or whoever uses these. And what we have had was some kind of localize had the wrong version number. And actually what this means is that we got a newer version, probably one that works together with Angular 13. And that new version of Angular localize had some problem, uses another library in a version that is incompatible with Angular compiler or whatever. So there is a library we do not even know about, that different library that we actually use in different incompatible versions. Usually that should not happen. So that is why we use this npm, this node package manager. npm is in charge of detecting these problems and solving them. And npm is actually doing a pretty good job at this. And it will actually tell you if you use version 13.1.0 of this localized stuff, then I cannot actually create a consistent list of packages for you. Please do use another version or update some other versions such that this conflict is resolved. And for some reason, npm on my computer was fine with this thing, and npm on Heroku was not fine with this thing. And we have had, actually, we were fixing this then after the lecture, Max and I, but actually just do it again. Remove the node modules where all the libraries live, and remove, so it was the shop, and then it was the front end, and to remove this package lock JSON. What is in this one actually? Well, actually, there it stores, I'm using the version blah, blah, blah of that, and that uses the other versions, and so on and so on. And here's, for example, this Babel stuff, and here you can actually see this. And this is something that package or npm actually uses internally to, have summarized information about what's going on in the node modules directory, and then actually decide on, is it okay to install this new version? And what else needs to be updated and these kinds of stuff. And yeah, if you remove the node modules, it's probably a good idea to remove the package -log JSON too, because well, that one should reflect each other. And if you change one of these, you should change the other one too. Okay, after the second or third try, it actually worked. The problem that I actually ran into is that the node package manager, the NPM, on my machine, on a Windows machine, worked differently from the one in Heroku. Because Heroku is running on Linux. It's actually probably Ubuntu or something. It's probably popular these days. And I know this problem from my young times, from the early 90s, where we actually had these problems very frequently. That was the time that Windows or Microsoft computers were pretty small, and you would not like to actually develop software in these. The PCs just did not have enough power to run an IDE, a development environment. And therefore, they were actually, well, too small to run a compiler after all. And so what you did is you were compiling your program and you were running, you were developing on a, well, Unix machine. It was probably a Sun workstation or something like that. And then you would actually put your program over to a Windows machine. And well, those operating systems are quite close to each other. However, they are different in some details. There's this nasty problem with slash and backslash for files and directories. There is this problem with character return line feed or just line feed. There is more seriously the problem with file names and upper and lowercase distinction. So Linux distinguishes a file named just F with an uppercase F from a file named just lowercase f. So in Unix, these are two different files. In Linux, this is just the same. Sorry. In Linux, this is two files. Microsoft, this is one file. So in Microsoft, for some reason, so when Bill Gates did the first DOS version in 1980 something, 86, 84 or something there, he just said, okay, don't care uppercase, lowercase. That's easier. And this is in the old times, that was the frequent thing that you did. And yeah, sorry. And we still have this problem. And actually, I still have the problem that I transfer a program from my computer to a Sun computer, and suddenly it doesn't, I can't find that file anymore. Because that file has been created in lowercase, and under Windows, I'm accessing it with an uppercase. I look it up for an uppercase F. And yeah. It works fine on Windows, it doesn't work on Linux, it just says, no, I don't find that file. In those old days, in the 90s, we finally learned, in order to develop a program that runs on a certain platform, you should be developing on that same platform. Your program is supposed to be running on Microsoft, your working environment should be Microsoft. Your program is supposed to run under Linux. Your environment should be Linux. You should be developing on Linux, and we didn't do that. And that's causing some of these problems. And actually, what we should do is use a Docker container that has Visual Code on it. And then actually deploy this Docker container to Heroku, and then develop on that one directly. Yeah, that would be a good idea. So Max is looking at me. This old man is saying stupid things. Well, he's too young. So, come on. So, nothing that we actually can solve here today. So actually, if you go for a professional industrial project, the thing that you need to do is set up scripts that do this testing and deployment fully automatically and regularly. On every commit, you actually do this automatically. Actually, pretty much what Heroku does for us. On any commit, it actually runs this whole chain, running all tests, do the deployment, and these kinds of stuff. And you do it so frequently that it's actually fully automatic, and then it works quite well. And then you, well, at least are aware of problems very soon. Actually, usually you have a three-step deployment chain. You have your local environment where you develop, then you have a staging computer where you first time try to set up your service together with other services. And when this actually works, then you actually go for production, which is another step. And on production, you still have something like a monitor that is certain program running or looking at your services and ask them, are you still well? Are you feeling good about this? And that's reading the log files and looking for error messages and these kinds of stuff. So most of these things are actually content of the DevOps technologies lecture in the master course of computer science here at Kassel University. And you might go to that one next term or once you have finished your bachelor or whatever. So what else needs to be done in order to get these things running? So we were pretty much done last week. And all the things that we needed to do was to go for Microsoft backend. So actually we were managing to tell our front end to open the right port. And we were managing to tell our front end to contact the right backend via heroku.app. That's an easy one. And what we not yet did achieve is that those shop backend and the warehouse backend, that they were talking to each other. That was missing. So that is actually the last thing that I need to add to you. And therefore, actually, it is the app controller of the backend. It's somewhere here, where I actually added a shop URL and warehouse URL. And that is by default localhost 3100 and 3000. And in the constructor, so why not there, I actually said if my port is different from 3100 and this I get from process env port here, if that is set, I use that one. If it's not that, I use 3100. And if I actually have a Heroku port, I use shop URL from Heroku and warehouse URL also from Heroku. And then I need to go for all these steps where this is actually used. So this is a subscribe at warehouse and these kinds of stuff. And actually, I probably did it in builder service. No, I didn't need to do that. There should be a publish here somewhere. Yeah, and the publisher uses just the subscribers URL. That is the one that I'm using when I start doing the connection. So that one is fine. So it's basically actually just the app controller that needs this little fix here. And then we are done. Great. And let's have a check on this. So it should be something like a Zindorf shop backend. Looks good for me. This takes, of course, a lot of time because the Heroku machine needs to wake up. And let's go for the warehouse backend. That one runs either. So why? Probably because the shop tried to connect to the warehouse. And that might have done the trick. And then we go for the front end. Yeehaw. This again still needs some time because this one needs to wake up. That's okay.
In that time, you have a few questions in the chat.
Yeah, you're right. So there's in the chat, it says Heroku exposes the application on port 3000 to 60,000. So there is a slight chance that by accident, Heroku deploys you on 3000 or 3100, and that one actually fails. So yeah, it's not actually battle-proof yet. So don't use 3000 and 3100, but something that is below 3000, and then you are fine. Yeah, it's a very slim chance, but yeah, you should not do that. You're completely right. Thank you for this advice. So we are ready now. So actually, you guys should all be able to go for Asendorf warehouse front end and to store some pallets here. Please, would you guys go and add some pallets to my warehouse? I just want to see this working. And so, who will be first? Come on, go for it. So we are still 5. Still 5. It's 5. Still no one able to actually do this? Still 5. Hey, there's a how do you spell that? Pronounce that? Giraffe? Okay. Giraffe here. Cool. Hey, that did work. So you guys are able to actually access this. That's really cool. And the big question is if I go for Asendorf shop front end, hard stotters, I love it. Oh, it's Valentine's Days. I hope everybody had thought about thanking his or her spouse today. And that one is empty. That's bad. And I should go for stotters. Yeah, please. Come on. So where are these stotters? No, it's offers, oder? Come on.
Well, it's our task. You had it in the suggestions already.
Thank you. Here we are. Oh, yeah. And so please could you add a price to Giraffe? Best lecture. Hey, love it. A Berliner. Very cool. How about a hamburger? Do not mob the hamburger. Okay, here we are. Hey, how did you do this? Smiley in here. That's cool. So it seems to work. So we added something to the warehouse, and actually our shop knows about it. That's pretty cool. So that's an easy one. And oh, giraffes are, yeah, it's not too expensive after all. It's a huge animal. So I actually can buy it on sale today. We have giraffe. That's so cool. Oh, I want one. Doesn't work. Cannot go into it. It's for Albert. Yeah. And it goes to Unicastle. Yeah, do send me one. And yeah, I have a giraffe in my state and it did work great. Everything is great. There's one additional thing that we need to think about that is in the back end, actually in the builder module. No, in the builder service. Yeah, I think it's the builder service. Somewhere here, no, it's actually the builder module. Here it says I have an Windstorm product orders these access to our Mongo database at Atlas. And actually the builder service has had something like this on module in it, reset. So it's deleting our database. On program start. Well, let's think about it. And no, we shouldn't do that any longer. So actually what we should do is, if we are in production, so our port is certain something or whatever, how we decide on that, then we should not actually clear the old database. And actually the clear command is something that we offer at our user interface. We would actually again say, no, if I'm on production, don't do it. And so more. So there were quite a number of places in our code where we were actually doing something for debugging purposes and for, well, testing purposes and for restart enabling purposes. And we need to go thoroughly through all these things, that not on accident we are removing real world orders from real customers in production in a productive system. And yeah, actually it's pretty hard to test things that we did not forget one of these. Yeah, you probably learned it on the hard way. And so actually that is one of these things where development level and staging is actually made for, that on the staging level you might look for these problems and actually fix them. A very important step, don't forget that one, or your customers will be quite unhappy. And actually we have had quite some of these problems at ourselves. So we were setting up Cassandra database here at our site, which is a big data database that is able to distribute your data over multiple computers. And we did follow up all the setup steps and then did it, and it worked quite well for several days and was actually incorporating, well, tons of weather data. This was actually for weather forecasting. And at some day, some weekend, it was all gone. Oops. That's bad. And the reason for this is that per default, when you set up a Cassandra database, it's set up under /tmp/temp. Who knows what /temp is good for? /tmp, anybody? It's like the downloads directory in Windows, where you put all of the things that you download via your browser into it. And from time to time, to get more free disk space, you clean it up. And actually a TMP folder or directory is automatically cleaned up once a week or something like that, or once a day. That depends on your system, but time by time. So if you put your database in a temp directory, it's going to be removed by your operating system after some days. Oh, that's a bad idea. So yeah, we learned that the hard way. And after putting, well, it was not yet productive, but we were actually spending a whole week to add weather data from all over the planet and all over a year to this database, and then it was gone in a minute. Damn it. And we actually tried though 2 or 3 times because we didn't figure out what was the problem. It works all fine. You could add it, you could query for it, it's working, and then it's gone. Oops. And to actually identify these problems were quite a headache. Okay, you can actually Google that, and they help you for that. Here we are. Yeah, that's it. Okay. So the final assignment is to get your shop and warehouse frontend and backend on Heroku running and speaking to each other, and that you're able to actually go through the default scenario, adding some palette, adding a price, selling a good, and doing the picking. That's it. And that should actually work as soon as you connect those 2 backends to each other and you are done. And then this is what we would like to see on Thursday. Great. Okay, then you're done with this course, and we are happy to give you a good grade on this. And that's everything we want. And we have some wrap up to do. That is the final assignment and the change that you should do. So let's just close this up. Do I still have time? I was talking quite a lot.
Yes, you still have 1 hour.
Still have an hour, 45 minutes. Yeah, 55 minutes. Cool. Let's wrap up. So thank you for staying with me. That was not easy each week. Did anybody of you use TypeScript before this lecture? So it was new for everybody of you. Did anybody of you use Angular? Of course not. Or Nest or something like that. So it was a pretty quite long list of new things to each of you. And that was actually the challenge of this course after all. The basic architecture is not too critical. Actually, I think next year I'm going to clean it up a little bit more and come up with an architecture which should be even a little bit simpler by having a central common event store here in the middle and having no event store for the warehouse and the shop. So the warehouse and the shop will just have the Mongo database with the dedicated data structures, palette and product and offer and these kinds of stuff and order. And the general, I have an event store thing where you have this general event thing database that you use for history and for conflict resolution. There will be a common one for that is used by the other rows. If you have a fifth service in your database, you still have a local backend and front end for your shop and for your warehouse, but you will have number 5 service, a fifth service, in order to separate these things a little bit. And the reason for that is it's so hard to actually have a peer-to-peer system where the two backends are similar and they connect to each other. This was brain freezing, and I would like to come up with a simpler solution here where we have this common event service at like an event broker at the back end of our system, and then the warehouse backend and the shop backend are just connecting to this broker. And that's so much easier. So it was so easy to have, shop is connecting to the warehouse, and then having it mutually, that was really complicated, and I would like to get rid of that one. And actually, I could, handling these events, this was pretty confusing after all, how we do that in Mongo. And that would be much easier if you have it as a separated service, and your application can actually focus on the logical stuff. And actually, this event broker might be a common thing that we provide you with, and you do not need to care about. That is one of the things that I would like to change and to facilitate next year. So what you still have is you have a single page web application that runs on Angular. And we have servers done with Nest, which is just a more enhanced version of Express. Express is the one that everyone else uses in the web, but Nest was a really good decision. I love it. It is an event-based system. Next year we will have a dedicated event broker. We have these model editors. No, that we didn't have model. Soon we'll call it model services. We have learned HTTP communication. We do not use web sockets or socket-based communication. That needs to be discussed. For these kinds of microservices, I think this is a good idea to use it in this way. Socket HTTP-based, REST-based communication has the advantage we do not have an online connection all the time. So between two HTTP requests, one of your services may do a reboot. That's an easy one. And that should not do a lot of harm to your system. So in a HTTP REST-based system, it's much easier to actually update some of the microservices because they don't have a direct line to each other. And so it's not a problem with one of those that restart. Still, this is under discussion. So you can achieve the same with WebSockets too. And if you want HTTP communication, each of the participants, each backend needs to set up its own Express-based service and may need to accept HTTP requests because you want that each of the one can actually approach the other service. And it's not the busy waiting where one of the services is asking for, is there something new all the time? That's the thing that's pretty complicated to achieve. Not yet covered, continuous integration. This is what I was talking about the first half of the hour. Staging, these kinds of stuff, continuous deployment, runtime monitoring, are pretty complicated things. We didn't do authentication, so no one needs to log in. Well, actually, as soon as you set up your service to run on Heroku, everybody on the world can actually access this and store new pallets and change the prices of your products. And that is not what you want for a real world system or a productive system where you actually sell goods, and then you need protection for those functionalities, that those are only available to authorized people. And we didn't do that because authentication is so complicated to get it right. And in microservices, there are standard solutions for this that you should use here. However, then you need a more sophisticated deployment than we do with Heroku, and then we are in the DevOps course. So that's another course just on that. So we did NoSQL. So it was nice to use Mongo. It was actually simpler than using a relational database system. But when I was talking to Anna Malik some 3 weeks ago, he said, no, we don't use that in production. We use a Postgres relational database system. It's easier, and more people know about it, and we have more experience with it. And no, don't do that. And actually,
well, we can teach the people to use new technologies.
Yeah. I have this problem. So Max was telling, just teach the young people the good stuff, and then they have to convince the old people, which are already working on with the old stuff. So that's innovation. True, but if you develop software in a team with some 8 or 10 or 50 people, it's not good to be the only wise guy who knows better. And if there's a team of a dozen developers, and only one of them, the new guy on the block, new kid on the block, knows, oh, let's switch from the relational database to Mongo, it's much better. That's not going to work. If you develop software in a team, you rely on systems or languages or tools or things that most members of the team know about. Because, it's not just you developing this software, being responsible for it, but there should be multiple people who know that, and actually most of the people should know that. So that's actually a problem with agile software development and technical innovation. So software guys are pretty conservative if it comes to productive systems. They say, okay, I'm not going to switch to this new technology until it has proven to be battle-proof for about at least 5 better than or 8 or 10 years. That's really a problem for innovation these days. Okay, we have had to look at Mongo this year. We didn't look into microservice patterns too much. There's this C-core-S pattern, which is very important. And we are doing research on that one these days. That will become content of some other course. I have no idea which one. Scaling. So we have had this discussion on if your system grows larger in lines of code, in number of users per minute, in terabyte of data you deal with. Then you will finally run into borders of your current architectures. At some point in time, you will recognize, no, I can no longer deploy all my services on a single computer. It's no longer possible. And then you actually have to split it up. There is these different dimensions of growing or how to deal with this growing. And one idea is you could actually say, I have this shop front end. I might have a dozen or 2, 3, 4, 5, 100 computers running the shop front end. That's no problem. And because our shop front end is actually so-called stateless, there's no information that is stored in the browser client. All the information is in the Mongo database. So you can easily replicate the front-end services because it's only static content. And it's all the same if it runs on multiple computers. So that one should be an easy one. The backend. You can also replicate the backend with no problem because also our backend is actually stateless. If there is any a call coming in that is doing a write, so it's changing our database, well, it actually changes the database. And if there are 2 warehouse backends on different computers for being able to serve more customers, then they all have use the same database internally, and that's an easy one. You can do that. So we can actually replicate our backends too. When it becomes tricky is when you say, oh, I have only this single database. I want to replicate the database too. Then it becomes nasty. And actually, then you are pretty good off with something like Mongo. Mongo is made for this. However, this is, that's really tough thing. The problem here is your project need to be really big until you run into the problem that a single Mongo database isn't good enough for you and that you need to replicate it on multiple computers. And so there is about a handful, a dozen projects or software systems in the world that actually needs this. And those is Google, eBay, Amazon, Netflix. So the very big ones, and all the Chinese ones too, of course. And those have thousands of developers, 10,000 or 100,000 of developers who actually deal with these problems. They have dedicated groups that deal with these problems. And they were able to set this up for this big system. However, the documentation of the Mongo database that allows you to do this replication is written for these 10 groups. It's not for a freshman in computer science or in a Bachelor of Computer Science. And it's really hard to get help on these. And if you do an error on that, it destroys a lot of data. And so this is for more mature people than you are. Sorry for that. Still, might look into this. Go for our DevOps course, of course. What you can do is actually to improve your performance, you can split your data in multiple partitions and say, okay, I have running shop in Europe and one in Africa. There's no reason why this is on the same computer because well, there is no offer for both continents too at the same time. And I actually can split all my customers that are sitting in Europe from all my customers and sitting in Africa, and then actually put this in different computers. That's an easy one. You can actually split your data if you have an idea that there is a logical group of data that can go there that is separate from the other logical group. So if you do this, it becomes harder to do a comparison of those two kinds of customers, on those European customers and these kinds of stuff. And so the big systems do these kinds of comparisons a lot, where you actually do something like, oh, customers that were buying this book were also buying these other books. This is a very common technique that you use by Amazon and in other of these systems. And so if you are doing this on the African server, you can only know about, so African people buying these books, buying these other books, and you do not know about how do the European people deal with these. And well, you need to do more complicated setups in order to solve these problems too. This one here, this y-axis is when you actually split your monolithic service into multiple microservices. This is what we actually did by splitting the warehouse and the shop. And so there you use something that you know about this. This is something which is pretty new. It's about 8 years old or 10 years, these ideas. That you can actually split a monolithic service into multiple smaller services. And you do so in order, well, so why do we do that? We could have set up the whole system in a single service, and that would have helped us a lot. Avoiding this event store stuff that we would not need to deal with, this connecting of the two backends and these kinds of stuff. Your whole system would have been so much simpler. And it's the default way. All other people in your team know about that. And that was really an easy one. However, in this course, I split this up on purpose in order to learn it. So if you do such a split, what is actually the thing that you need to do and to evolve about that? And there's more. So this is a brand new field of research, and there's very little experience in the world how to actually do this. And we have a lot of discussions in our group. And if you're looking for a topic for your bachelor or master's thesis, there you can actually do a lot of work. There is a lot of interesting topics up. Okay, we have that one, scaling. Let's go for event loaders. No, it's down here. Covered. Follow up, yeah. So finally, just go for our web engineering course. It will be up, I have no idea when again. That is a master course after all too. And that is run by the Ticket Toaster people who actually do know much more about dealing with 100,000 customers in a minute. And then you need, well, quite some experience. You run into, there are pitfalls everywhere that you run into and that you only learn when it comes to these peak uses. And you need a lot of experience on that, and web engineering is actually dealing with this. And DevOps I have talked about a lot of. Okay, here we are. Thanks for listening. See you guys soon in one of the other courses. For the people in Douala, I'm going to visit you. I'm going to travel on April 23rd, and I'll stay in Douala for about 4 weeks. And there will be a 3-week course with lectures every day on software engineering after all. And there will be a workshop at the very end of this. And this workshop is synced of having local people from Douala, which is you guys, doing a proposal how you can use what you have learned in the microservice course to set up a service, for example, in Cameroon or in Douala or in Africa. Perhaps you start slow and then you grow up. Because, well, setting up something like, well, Amazon is big in Europe. I'm not sure how big it is in Douala. If you do not yet have it, you might want it. Or actually, no, there is no need for, well, a book delivery service or a goods delivery service. In Douala, I have no idea because there are other alternatives for that. Actually, developing such a service, I cannot do this from Europe. So no European, no American, no Indian, no Chinese country can actually develop a good service that fits the needs of the people of Cameroon or Douala because, well, we do not know the culture. That's it. I have no idea how life is working. Where do you buy food? When do you buy food? Where do you buy goods? Where do you buy computers? How do you deal this? Do you need Uber? Have you Uber at Douala? No Uber. So why don't you develop it? So is there no need for Douala? So is public transportation so good that you don't need it? Or so what is it? Or is it prohibited by law? Or so there is quite. I've learned that in Africa and in Cameroon too, you do pay by phone a lot, which is completely unknown in Germany. At least it's known in some European, but it's actually not used in Europe that much. We do credit cards. It's getting bigger these days, but actually, do you pay per phone? It's still back up by credit card and not actually your mobile account, is it? So yeah, there's huge cultural differences. How life works in your country and in other countries, and perhaps only you guys can actually say, oh yeah, this is a problem where we could set up a computer server that the people would love to use. And actually, you say, oh well, the people don't have smartphones. We need something which is working with message services, SMS or something like that. I have no idea. It is you who knows your local country, and now you know the technology. And so what I would love to see is that you people come up with an idea for a small enterprise that would run and work in Douala. And then we can actually work on that idea for some week and get, feedback from other users and do some trial and get ideas on how we would do that technically and these kinds of stuff. Do you have cloud server farms at Cameroon and Douala? I have no idea. So where would you actually rent a cloud service? A computer to rent somewhere? So why don't you set it up? That would be nice. And these kind no. Manji said, no way. Okay. There's a lot of things that we could have to discuss for. So what kind of software would be really helpful for people in Douala and Cameroon and in Africa? And how is this different from software that's already there in Europe or the US or China and India? And so what would be a good idea to have a new service for the people available? Thank you, guys. I hope to see you again soon. Also, the German people, I hope to see in the other courses soon. And then please do your thesis at my group in order to bring this microservices research forward a lot. Thank you and goodbye. And yeah, thanks for listening. Bye.